Yesterday we looked at the last couple questions on the FET lab, and some of y'all got that turned in.
I say if we do the force diagrams, finish that, and then do the projectile motion.
Sounds like a plan then. Okay, cool.
Now that we have a whole period.
Yes. Indeed. Okay, so let me move that out of the way. All right, so yeah. So as I recall, we got done with the front page of this guy. Got everything on there. It's been a while though.
I still need to catch up on the front page of that.
Oh. I think I did video it, right? Maybe.
I don't know. I know one thing you did in video.
All right. You know what? I'm going to totally go look at my YouTube channel and see here. YouTube channel. Yes. Hey. Now, by the way, the West Texas High School Science YouTube channel is a super handy resource because yeah, totally subscribe. Share, like, and subscribe, y'all. But if you take a look, I've got just at the top here just all of my recent uploads in reverse order. But I've also got everything sorted out by playlist. And so the most recent playlist has been Forces and Newton's Laws. I guess, I don't know, but yeah, I don't do it for the love. I don't get paid, for this. But anyway, let's see. Friction and free body diagrams. That was the free body force diagrams lecture and practice. There it is, right there. Pickles. So let's see how far we actually got. Oh, that's weird. I'm videoing a video of me videoing a video. Let's move ahead here. So there's some stuff about free body diagrams. I think I switch over. Okay, cool. Yep. How far did we get?
I thought we got the whole first page.
Well, you did on video.
Yeah.
I was here for that, and I think y'all did some more of it when I was gone or something.
Oh yeah, we got up to the monkey. We ran past the monkey, right?
Okay.
I know, I'm talking about
Okay. So yeah, it looks like we made it up through number 5 or so together.
Yeah, that was the monkey.
Okay. So yeah, I'll be happy to go back. I'm not just going to show you the answers because that's lame, but I'll be happy to go back and we can talk about any that you didn't get on the front. And don't show each other the answers either because that's lame and cheating.
I think we're just gonna get the first ones that are video.
Oh, well.
Yeah, I just didn't get the.
Well, perfect because they're in the video. Okay, now you know where to find them. But yeah, and I've got down here an entire playlist with just all of the FET simulations that I've ever done and stuff. And so, also, hey, there's some tech support down here for how to use.
Yes. Just quick part of interruption. I need all seniors who are enrolled in dual credit for next semester to please go to the Commons and meet Ms. Franklin at this time. Thank you.
All right. Is that you? You're taking dual credit?
Yeah.
Okay, cool.
I should be taking college.
Yeah, she's just going to say what she said in the message yesterday, which is, hey, we're going to be paying full price next semester.
Oh, next semester, right? You said next year.
Actually, she may say more than that. I don't know. I'm not going to put words in her mouth. But anyway, it's all there, so go knock yourself out. Yeah, this one stupid video I made kind of as a test thing, telling people how to use Zoom on a Chromebook, it's got close to 4,000 views.
Oh, I see it.
Which is ridiculous.
Everyone wanted to know.
I guess so. If it helped people out, that's glorious. I know, right? It's anything that I make to be deliberately entertaining, nobody ever watches except my mom. And she doesn't count somehow. Okay, Mom, if you're watching this, I don't mean it. You totally count. I love you. Okay, so let's take a look. I'll go where you'd like to go.
I think we're on 13.
I think we are.
I mean, there's nothing on that.
I mean, it's a little bit lame for me to just go through and work them all. I think somebody was griping in our survey about how, you just doing all the work, we don't really learn anything. And I agree. I'm not going to do that.
Can they not hear us talk?
And so whoever it is that wrote that, I'm not going to review you because I don't know who you are, but hide because they're coming for you. An electrical line sags between two poles. All right. So The thing we're actually going to be diagramming would be the line, right? So I'll make my line kind of a long box. So if it sags between two poles, what forces are acting on that line?
Gravity.
Okay, so we've got force of gravity, right? Is there a normal force?
Yeah. No, because it's not sitting on something.
Exactly, it's not on a surface. So what's keeping it from falling? The two poles, right? So what direction are the poles pulling?
Opposite from each other.
Okay, would it be straight left and right?
No, it would be straight.
I think it's, yeah, because it's going to be kind of like that and kind of like that, right? Because you're going to have force of pole, that's a P, not enough. You're going to have force of pole 1, or force of tension 1. And you're going to have force of pole, or force of tension 2. That's it, right?
Are they equal?
That's a good question. It doesn't say. I'm going to assume if it's sagging, then the saggiest part is going to be dead between the two. If you assume that they're hanging at the same height. And it doesn't tell us to not assume that, so I'm going to go ahead and assume that. Oh, you mean should we go ahead and mark them as congruent?
Yeah.
Why the heck not? Works for me. And so, just kind of talking off to the side here, if we were to take this situation and actually look at these, if we looked at just the y component of both of those, like this here and this here, if you add them up, they're going to be equal and opposite to that down there. Okay, to keep it balanced. Good thing to keep in mind. All right. How about y'all tell me what to do on 14? Okay. Expertly drawn elevator. Okay. Okay, force the cable. Okay, going up. How is its arrow going to compare with the gravity arrow? It's going to be bigger, right? And we know that because it's accelerating upward. So I may not have left myself enough room here. Let's make it smaller here. We'll do force of gravity here. We'll do, we call that force of cable. Force of tension. That works for me. All right. Questions? Oh, I like 15. You tell me. What do we do? Drop parachute. It's okay. This one's going to be tough. Nailed it. Okay. Uh-huh. Uh-huh. She is descending downwards, but she is slowing down, right? So which force is going to be greater, the force from the parachute or the force from gravity? Right. At some point, she's going to stop slowing down as she falls, and she's just going to fall at a constant rate. And at that point, those two arrows would be equal. Okay. Let's see. I don't see a Tatum, so I'm going to go ahead and mark her absent. Or Tatum. She'll watch this later. Y'all can tell her hi if you want to.
What's up?
All right. I felt that. Okay. 16 then?
Yeah.
Draw a truck. Okay. Okay. All right. So we're going to put a road underneath it. So we're going to have force of gravity and force normal. Those are going to be congruent, right? Okay, cool. Traveling eastward at a constant velocity. Okay, so it says consider air resistance and friction, okay?
So friction would be pulling it that way.
Friction would be pulling it back, right? So we've got force of friction. You can kind of see that that's an F of an F. Okay, what else?
There's another force going that way, but would it be the same?
Going which way, to the left or to the right? Okay, all right. So what is driving the truck forward? Okay, so we can say force of engine. Okay, is there anything else acting that it wants us to pick with? Force of air resistance. Okay, so we'll put force of air. Now, this one force is not going to be congruent to either of these, but those two added together would be the same as that if it's moving at constant velocity. So that would make it a balanced force. Good question. Okay, we good so far? Only 2 to go. Holy cats, we're going to be done before Darius gets back.
And Darius is the one who won.
Right? Y'all can tell him to go watch the video later. All right. A truck is accelerating eastward. Consider air resistance and friction. Oh, I see what they did here. So it's going to be pretty much exactly what we had for 16, except it's going to be different how?
So instead of going at a constant velocity,
Right. So how do we show that with our arrows?
we do favor
Which one?
forward.
The force of engine. So it's going to be identical to that, except the force of engine is going to be larger. Now I'm willing to bet that that's probably going to cause the force of air to increase a little bit too, right? Okay, but still the force of engine is going to be bigger than the air and the friction put together. So I'm not going to redraw that one. Ooh, a truck is traveling up an incline at constant velocity. Cool. All right. Truck. Wow, that is a coked up truck. What is going on here? All right. Whee. ATV. All right. So, help me out here. Gravity is pulling what direction?
Down,
Uh-huh.
not.
Good. Gravity always pulls toward the center of the earth. Good. Where's the normal going to pull? Is it going to be straight up? No. Right. It's perpendicular, right? It's always perpendicular to the surface it's resting on. Okay, down?
Well, like the slope. Yeah.
Okay, down the slope. Yeah, that works. Okay. So we're going to have F of air. We're going to have F of F, force of friction. Okay. And then, okay, force of engine going this way. Okay. Now, if we wanted to be sure that it was moving at constant velocity, this is another one that's kind of fun to take apart because we got all kinds of fun things. So if we just look at each one of these vectors, okay, so the force of engine, you know what, let me zip this down a little bit. Zip. The force of engine is going to have an x component and a y component. The normal force is going to have an x component, or you know what I mean, x component and a y component. And notice that this x is actually pulling back away from the direction that he's trying to go, right? Okay. Both of these down here, the F of air and the F of friction, are going to have an x going backward and a y going up. And then gravity is just going to be straight down, just all y. So look at all of this. If you had to like sum up all of the x's and all of the y's, look at how many x's are pulling back. That means that this x right here has to be equal to all three of these put together in order for it to be constant. And then, since gravity is the only thing pulling straight down, that means that all of these y's right here added together have to be equal to gravity to keep the car from sinking through the ground or from flying away. So, now, if you were then given, like, the values for all of these, if you were given, like, it's using so many newtons of force at an angle going up this way, and gravity is pulling with this many newtons based on the mass, and normal force is going to be this many and stuff like that, you could trig your way into finding any of those x's and y's that were missing if you knew the rest of them. Okay, that's something that would take you a lot of paper and a lot of details to make sure you weren't leaving anything out, but it would be entirely possible to do. Okay, and we've done that kind of thing. So,
Which question are you on?
Darius, I got bad news for you. We just finished.
Oh.
Good
That's
news
why
is,
everyone was looking at me.
good news is I got it all on camera, so you can go back and watch it. So,
I did too.
table flips. I love it. All right. Hard to flip a desk when you're sitting in it, though. I tried. The physics aren't working with you there. Okay, so
Can we turn this in?
you can totally turn this in if you're done, and if you're
No.
not, then you can
Watch the video, right?
you can go back and watch the video. That's right. So let's move on. Since we finished out free body diagrams, that's beautiful. We've got Newton's laws and we've got projectile motion. Where do you want to go to? Okay, let's hear some votes. 2 votes for back page of Newton. Raise your hands.
I'll vote we do the free body diagrams.
You know what? We did. You win.
That's just where I'm
I'm
sitting.
sorry, most of us were here. I don't know what to tell you, man.
I still need to give you a copy. Yeah.
Of the... No, I don't think I did. Did I check my extra copy yesterday? See if I have one there? No.
Not for the projectile motion, you did for the Newton's law.
Gooey and fudge. Okay. So, no, I haven't yet, but I can get one made. I just need to remind myself to go get one made.
Or maybe we'll know.
4.67.
Oh, here's my master copy. I'll tell you what, Jason, do you know how to use the copier in there to do like both sides of duplex and all that? Okay.
That was the third stone.
Bring back, go make yourself a copy and bring back my originals, please.
Go in there and be like, hey, can you make a copy?
Well, you might see who's working and, ask nicely. So, who wants to work on more projectile motion?
Me.
Yay, let's do that. Projectile motion or free fall. Good times then. All right, so do you want to kick off and just go from number 9 and just keep on trucking, or do you want to skip around some?
Yeah, we'll just work them in order.
Ah, that's boring, but okay.
Can we go backwards?
Why?
I don't know, that's what I do on my test.
Like start at the end and work your way back?
Well, I tried to do the first one, then I know I can't do it, so I go from the back.
Do that.
Maybe we could try it. We could start with 15 and go forward. Anybody have any objections?
I do.
Okay.
I think it's weird. No.
You know what? In space, there is no up or down.
Oh wait, this one's frozen.
I just read more about it.
Okay. You know what? This one is actually just an acceleration problem. Okay, so that's not a free fall. So 15 is easy.
Yeah, exactly. See?
We'll skip 15.
Well,
Ah.
15.
You could. Oh, okay. Look, that's All right. Well, okay. No, we've got okay. That's going back to acceleration stuff. I mean, that's like before we did projectile motion stuff.
Interestingly enough, I don't remember that, so can you please do it?
I'll make you a compromise. I'll give you the formulas you need.
Okay, yes.
Okay.
I mean, just go with
All right.
that.
So look. All right. So if you've got, let me move that off of my head there. So acceleration is equal to delta v divided by delta t. Okay. Delta v is change in velocity. Delta v is equal to vf minus vo, final velocity minus initial, and delta t, that's just change in time. I mean, do I really need to tell you how to find change in time? Final time minus starting time, it's the same kind of thing. Okay, so if you've got a car initially at rest accelerating uniformly at a rate of da-da-da-da, the car travels that many things, what's its final velocity? Now, you can still use big 5 for this. You can totally still use big 5 for this because acceleration's constant. Okay? So,
Wait a second now.
maybe
Wait.
here. I'm waiting.
Wait, can I see that thing again?
Yeah, yeah.
Okay.
Yeah, there you go.
Well, so, no, that's acceleration. Man, I almost got you there.
She almost big brain.
But we don't have,
Okay.
Could we use big 5 number 2?
Probably. Let's see. All right, big 5 number 2.
I just don't know where it's at.
Okay. So VF equals, okay. VF equals VO plus AT. Okay. So that right there would be delta X. Do you agree? That's distance.
Yes.
Okay. VO is 0. VF is, well, it doesn't have VF, but it has A. You're finding VF. So look here. You've got VO is 0. You've got A is 6. You've got delta X is 108. So you're trying to find VF. Okay? You don't need T. So you can use big 5, 5.
why do I vaguely remember doing this?
Because we've kind of done this or went a lot like this.
Yeah, no, there it is. It's just not really.
See now, since big 5 number 5, check it. If VF squared equals VO squared plus 2A delta X, if VO is 0, then you can get rid of it and just say VF squared equals 2A delta X. So you do 2 times acceleration times distance, and then take the square root. I'm not going to do the rest of it for you. I just told you how to do it. Let's look at 14. See now this, that's worth our time. Let's look at 14. Okay. The ball is thrown horizontally at 16 meters per second. The ball travels a horizontal distance of 80 meters before hitting the ground. From what height was the ball thrown? I love it. Okay, so we've got the ball being thrown from a thing, and it's being thrown horizontally, which means it's going to follow parabolic flight path until it goes boom, right?
Yes.
Thrown horizontally at 16 meters per second. So that is its v of x, right?
Yes.
Okay. Travels a horizontal distance of 80 meters. So that's going to be our delta x. Okay. From what height? Yes, we are trying to find delta y. I've moved on, Jason. No. Okay, now say what again? I'm sorry. 108 is delta x, yes. Okay.
Okay, question. Is it a 90-degree angle right there?
From where it's thrown? Yeah, if it's thrown horizontally.
Okay, so couldn't we use this to find delta y?
No. Oh, wait, that and that?
Yeah.
Well, except that we don't have an angle right here, and we don't have an angle right here.
Could we not use the 90?
No. You can't do it with 90 because they're all going to be 90 when you're doing right triangles. You have to have one of the other angles, or you have to have both. You have to have any two sides. Okay. Sorry, no, we can't go straight there. But make your XY table. Let's talk about what we do know.
We know v of x.
Okay, we know v of x. That's going to be 16, right? Okay.
So delta x.
We know delta x. That's 80. Okay. We know acceleration on y. A is going to be 9.8 or 10. They tell us to use 10, but we're going to be traditionalists here. Do we know VO or VF?
VO should be 0, right?
Yes, VO is 0 because it hasn't started falling yet. VF we don't know, but it turns out we probably won't need. Right, so our first big thing we need to find is hang time, right? We can find that really easy over here. Because if it went 80 meters and it was going 60 meters a second, 80 divided by 16 will tell you how many seconds.
5.
Okay? Is that right?
Yes.
Okay, cool. So t then is going to equal 5 seconds. So if t equals 5, now we're trying to find the height, we're trying to find the delta y here, correct? So hit me with some ideas. What do we want to use?
3.
Big 5, 3? Okay, I love it, yep. So delta y equals VOT, which we don't need because VO is 0. So we can just say that delta y equals 1/2 AT squared.
Yes.
Okay, so t is 5, so t squared is 25. 25 times 10 is 250. Divided by 2, that's 125. So it's going to be awfully close to 125 meters. Oh, hey. That's not too bad.
Can you move the little Mr. King?
That's hurtful. Yeah, sure. Just sit here and watch you very large lady things. I see you down there. Okay. Nice, I could also scoot the camera up a little bit. That would help. I could put myself back in the corner. Nobody puts King in the corner.
Haha, I see what you did there.
Right. Okay. We happy? Have we moved on? Or you got a question?
Yeah.
Yeah.
So on number 15, it has 236s.
Huh.
We'll figure that out.
Well, then you're not going to go wrong picking either.
But it kind of fits both.
See, that kind of thing just gets thrown in to freak out your honors kids.
Good thing we are honors.
It's like, what do we do? What do we do? How do we handle this?
Well, wouldn't we?
I don't know. I don't know what to believe anymore. What?
Wouldn't we technically be your honors class?
No, because
For physics,
no.
technically.
I think physics ought to be considered honors, but that's just me.
Stuff would count as a check one count, so, yeah.
Oh, quit your complaining.
No, because I failed on this one.
Ah.
No, I made a really good grade on one.
All right.
I'll make a really good grade on one.
But okay, so how much of that is cause and effect, though? How much of it is, well, I know this isn't really going to cost that much, so I'm going to try hard, but if I don't get it, meh.
I do actually really try hard. Okay. Because I'm scared that you're going to be like, oh, this counts now.
Yeah. Spoiler, it's always counted. You just never knew. Okay.
Okay, no,
All right, so do we want to keep going backwards with 13? See, now they're just throwing voodoo numbers at us here.
Yeah.
A boy throws a ball at 32 radical 2 meters per second at a 45-degree angle with the ground. Okay. Sure.
Well, now we have an angle.
I think this boy is a robot because, he's using weird numbers. So find out where this robot boy was made. Probably Japan. Okay. So find the horizontal distance the ball flies. Okay, sure.
So would that be?
I'm going to go ahead and change that into a real number because that's ridiculous.
It's like 45.
32 times 42. 45.25, I love it. They're doing that assuming that we're not using sine, cosine, tangent on our calculators and we're like resorting to square roots to find our distances and things. We're beyond that. So he throws it at a 45-degree angle with the ground. Okay? Perfect. And at 45.25 meters per second. So we want to find the horizontal distance the ball flies.
Wait.
Yes.
I think I'm, never mind.
So we're tracing the complete flight path. We can divide it into the upside and the downside. Okay. And so since that's 45.25, I'm willing to bet that we can find our v of x and our VO of y relatively easily, right?
Yeah, 45, 45, 90.
It is a 45, 45, 90.
No way.
So if we were to square 45.25, so let me square this, then I get 2048.
2048.
Uh-huh. Now, that's equal to that plus that, so let's divide this in half. So 1024 is going to be one of the sides squared, so let's take the square root of that. Okay, perfect. So that's 32. And so are you. Okay? Groovy.
So, and you just use the path of that dude, right?
Pythagoras.
Yeah.
Totally did.
Wait.
I jumped. Do I need to back up?
No. I'm just done.
Alright, so let's construct an XY table here. Now what we know. We know A is going to equal, for the first, let's just do half at a time because we can always double our distance. We'll find our delta x and then we'll remember to go times 2. So just looking at the upward half, we know our acceleration is negative 10 or negative 9.8. We know our VO is 32. And then at the top of the path here, our VF is going to equal 0, right? Okay. We don't know time yet. We're going to need to find time. We don't know our delta x. So what we're looking for, times 2. We do know our v of x is also 32.
Question.
Shoot.
So big file number 5 doesn't use t. Is
You're
there
right.
a way we can rearrange it to where that delta x is in the front of delta x?
We don't have to.
But we don't need to find delta y though. So we don't need to find how high up it goes. We just
I thought
need to find,
Oh, we have.
we're looking for horizontal distance.
Yeah, I thought we were looking for delta x.
Yeah, but you can't use this stuff from the Y side.
Oh, okay.
She's exactly right, yeah. If you were using this stuff, you'd have to make that 2a delta y, not 2a
We don't
delta
have
x.
the for that.
Right. So we are going to have to go find time. And I think our easiest way to find time is going to be either using probably big 5 number 4, don't you think? Or can y'all, or we could go find our average velocity. No, that wouldn't help.
Question.
Shoot.
Could we use, JK. Oh yeah, number 2.
See, I was thinking that myself. Okay.
Yeah.
To find time.
Okay,
That does seem like it would be a lot faster. I like it, Emma. Good call. So VF equals VO plus AT. All right, cool. Since VF is 0, so negative VO equals AT. So negative VO over A, like you say. Yeah. And equal T. And so we're going to go negative 32 over pencil, negative 10. So 32 divided by 10 is going to be 3.2 seconds. You agree? So now that we've got 3.2, that's 3.2 seconds here and 3.2 seconds here for a grand total of 6.4 seconds. So then let's just go delta x equals v times t. So big 5 number 1. So 6.4 times 32. I'm not going to do that in my head. I get 204.8 meters.
Hey,
But
that's
you
what
gotta
they
hold-
got.
Nope, I already did because I doubled my time. Okay. Now, you could have gone just 3.2 times 32 and then doubled that. It would have given you the same thing. Okay. So 204.8. Let's see.
Then look at us, though.
Woo! Look at that. Gorgeous.
What's on it?
It is, well, we've been talking for 35 minutes now. That's a long video. I think I'm going to go ahead and can the video probably, but what time do we get out of here? 47 after? We got 10 minutes. Yeah, let's do one more. Oh, the monkey. Okay, remember I told you to tell you the story about the monkey and the hunter?
Yeah.
Okay, so it's been a while. I'm going to take an aside here because it's a totally related aside. So, let's say that you've got a hunter, okay, and we're going to make him a hunter because he's going to have a gun, okay, give him like a big old scope on there and stuff, pew pew. We're going to also give him like awesome, maybe like an awesome hunter's hat or something. He is out hunting in the jungle, and he spies up this big tall tree here. He spies a monkey, okay? So let's put the monkey up here. Let's give him like, big monkey ear. Oh, it's a Mickey Mouse. Oh dear. Yeah, okay. So maybe the monkey is, hey, I can't draw a monkey. How do you draw a monkey even? I can't draw a monkey, okay? Oh, he's got a tail. If it's got a long tail, it's a monkey. He's holding onto the tree here, sticking his tongue out, okay? That looks obscene. So anyway, this monkey's up this tree, and this hunter sights this monkey in. He pulls his trigger to shoot the monkey. At the same instant that he pulls his trigger, the monkey lets go and starts falling.
So
what happens?
I think he got got.
It totally gets him.
Okay. Alright, I thought so.
So now, can you tell me why?
Because the acceleration of the bullet is faster than gravitation.
I mean, it doesn't even matter how far away he is. This can be like this can be like way long delta x here. He's still going to hit that monkey. But can you tell me why?
Because he got great accuracy, duh.
Okay. Let me see if I can lead you to the river here. As soon as the monkey lets go of the tree, what force is acting on him?
Gravity.
So he is accelerating due to force of gravity at 9.8 meters per second down. Agree? So what? How do you figure?
Because he looked at the question.
Because
This has nothing to do.
Yeah, this has nothing to do with the question.
Yeah.
It just reminded me I was going to tell you all the thing. So it doesn't matter how fast the bullet's going.
What if it was going like 1 meter per
He's still going to hit the monkey.
second?
Okay, so as soon as the bullet, let's talk about the bullet for a minute. As soon as the bullet leaves the gun, what forces are acting on it?
Gravity.
Gravity. See, you've been supposing that when he shoots, the bullet's going to fly straight. It will not.
It's going to follow the curve of the earth.
It's going to follow a parabolic flight, and it's going to fall because it's also being accelerated by the force of gravity. It's also going to fall at 9.8 meters per second,
Oh my god.
which means it's going to fall at the same rate that the monkey falls, and it's going to get it.
Wait,
Well,
so if he just stayed there, would he still get hit?
no, he wouldn't.
See?
So if the monkey had been smart and not let go, stupid monkey, then the monkey might be alive. Because if you are shooting, and anyone who shoots knows this, I don't do a lot of shooting, but I know this because I teach physics, that if you are shooting something at a distance, you have to account for the fact that your projectile is going to fall as it flies, so you've got to correct upwards to account for that.
That's science.
Pretty cool, huh?
Yes, sir.
And I think that's all the physics we're going to physics today.
Say less.